Hello, I'm Brian Cox, and this is A Question of Science recorded here at the Francis Crick Institute. In each episode, we assemble a panel of world-leading experts to tackle your questions about some of the biggest scientific challenges we face today, from whether we can repair the aging brain to what is consciousness and how we'll adapt to climate change. But today, we're leaving the surface of the Earth and heading for the stars. Almost a fifth of the UK economy is dependent on space-based infrastructure. Satellites are central to many everyday tasks, from providing internet connectivity and weather forecasting to delivering timing information for financial transactions. The UK space industry alone is worth £17.5 billion a year, and the space economy globally is expected to grow to $1.8 trillion by the middle of the next decade. Over in the US, NASA is gearing up for the first crewed missions to the moon since 1972 and planning to build a base there, as a stepping stone perhaps to the asteroids, to Mars and beyond. And it may not be long before the majority of our raw materials and even power come from space. Today I'm joined by a stellar cast as we try to answer an increasingly urgent question: who owns space? And they are...
Hi, my name is Dr. Carly Howitt. I'm an Associate Professor of Space Instrumentation at the University of Oxford. Most of what I do is in the outer solar system, so asteroids, icy worlds, nothing much with an atmosphere, but everything from Jupiter to Pluto and beyond.
I'm Dr. Jill Stewart, and I'm an academic based at the London School of Economics, and I'm endorsed by the UK Home Office as an expert in the politics, ethics, and law of space exploration and exploitation.
And I'm Helen Sharman, first British astronaut, and I've always loved talking about science and space.
And I'm Sanjeev Gupta, Professor of Planetary Science at Imperial College London. And my day job is working on Mars from the comfort of usually my kitchen with a cup of tea.
And this is our panel. I thought, Sanjeev, you should just have stopped at working on Mars. It would have been great for the conspiracy theories, wouldn't it? I thought I'd start with a very broad question to you all, actually, which is, and we've given some examples in the introduction, why space is important, why we do space exploration. But maybe if I could just go around and get your initial thoughts.
I think there's really a lot to be learned, and I think there's so much we don't know. I think pure curiosity, exploration for the sake of exploring, and collaboration. Science and space in particular is somewhere where countries will have to work together to make it work. You know, despite what's going down on the Earth, the people on the ISS have to work together to make that happen, regardless of where they come from. And so I think for all those reasons, to inspire, to learn, for technology development, and just to see what's going on, I think it's a really fun and exciting thing to do.
Jill?
I absolutely agree with all of that. I also have to mention that it has traditionally been driven by politics, and so I think it reflects in interesting ways on geopolitics on Earth. And linked to that, for me, I think what's really interesting is how it kind of taps into the extremes of humanity. So sort of the underbelly of technology being used for military purposes, but then also this beautiful side, which is about exploration and, the human imperative to discover things.
And I suppose I was going to say as the realist on the panel, but in the sense of, being immersed in global politics. Because this idea that Carly mentioned of being forced to collaborate, and I think all the way back to Apollo-Soyuz, I suppose, is there still anything in that?
Absolutely. So outer space has long been a great way for countries to collaborate with each other, partly because it's so expensive, also for reasons of geography. So we need to have receiver stations all around the globe, but also kind of linked to competition as a way to shore up alliances. So, really the first space age was inspired by the Cold War. It was a useful cold way for the Soviet Union and the United States to compete with each other. So all of a sudden we had these huge budgets that allowed for this competition that brought us such amazing discoveries. And yes, that's very much still part of it today.
And Helen, of course, you flew on the Soyuz in the Soviet era to the space station. So that question about collaboration, you'll have a view on.
So I flew to the Mir space station, which was a Soviet space station, became a Russian station. But then International Space Station was designed with the Russians and the Americans absolutely having specific parts that the other nation state could not do without. So the Russians have the propulsion, and the Americans have all the navigation stuff. So you've got to have both of those, which is why that's probably one of the few truly collaborative projects left in recent times post-Ukraine invasion. Just because they have to keep it going. But generally, of course, we go into space also to do now not just the curiosity stuff, which is fantastic, of course it is, but we go to do practical science. So we are making medicines in space. We're bringing back protein crystals that we're then designing into new drugs on Earth. We're making new materials that one day will not only be used in space, but will be used on the ground. So we're doing it for the benefit of the Earth as well as curiosity.
Sanjeev.
Well, the flippant answer would be because it's there, why not? But really, from my perspective, I'm an accidental planetary scientist. I suddenly ended up by chance working on Mars. And when you look at the images that we collect with the Martian rovers and you see this beautiful arid landscapes of Mars, but desolate, not a sign of life, no trees, no greenery, what it does is actually makes me think how precious Earth is. So looking into space, looking at other planets actually helps you understand your own planet, our own home better. And I think that's really a valuable reason to go into space.
Well, thank you for those introductions. I think we'll go to the first question now, which is going to bring us from the romance of space to the practicalities with quite a bump.
I'm Sohan D'Souza. I'm wondering how much of a threat space junk poses, and in particular, whether it could become self-perpetuating. If so, what could be some of the mitigations or solutions? And do you think our increasingly anti-globalism governments will agree to take necessary steps to protect the space commons from it?
Jill, this sounds like your
Yes,
legal
this
aspect.
is my will. I can tell you the legal aspects for sure. So just really briefly, so outer space is mainly governed by 5 treaties. The Outer Space Treaty of 1967, which says that space is neutral territory and no country can claim any of it. The second one is the 1968 Rescue Agreement, which says that we have to be nice to astronauts if they crash on Earth. The third one that's relevant here is the Liability Convention. And this says that a country is responsible for every piece of debris. And what you're hinting at here is the Kessler syndrome, which is this idea that if one piece of debris hit another piece of debris, it would create a cascade effect. So it would, which would then spread out. And this is a genuine concern. We're tracking over 44,000 pieces of debris at any given time. There's something like 3,000 defunct satellites that are in space right now. And so, it's definitely a concern. I think there are reasons for hope. We are getting better at making sure that satellites can deorbit themselves at the end of their life. We're looking at debris removal procedures. And I can be a bit cynical about global politics, but one thing I will say is that nobody wins if they don't coordinate on this particular issue. So if we did have a Kessler syndrome scenario, it would be like the tragedy of the commons. No country has an interest in having their space infrastructure knocked out because we rely on space infrastructure so much every day.
So the problem is, though, that we can track these, the bigger lumps, so above about 5 centimetres. But below that, we just can't see them, let's say. We can't track them. And therefore, even 1 centimetre bit of debris will completely knock out a satellite. It can stop it from functioning. Anything above about 5 centimetres can explode it, right? We have tiny flecks of paint. We have exploded bits of batteries, exploded lumps of fuel that are now sort of dotted around in space, and they can all cause damage, and they do, So the outside of spacecraft are constantly being bombarded by this stuff. Astronauts see them, these pockmarks on the outside of the space station when they do spacewalks. I saw it on my window, right? So that it's all
must be unnerving.
Yeah. Well, we had double glazing.
Not triple glazing.
But no, it's serious. It is a big thing. So yeah, we can do a lot better in terms of bringing down our third final rocket stages and so on. But there is no technology yet, even hopeful, that we can get rid of the smaller bits, the smaller clouds. So we've got to stop creating them.
I think working together, especially to clear the debris in certain regions of space. So some are more, space is big, but some regions are really valuable, right? If you want to have a geostationary satellite, so that means your satellite is looking at one area of the globe all the time, which is incredibly useful for things like communications or weather mapping, all those sorts of things. That's very, very narrow altitude you can sit your satellite at. And those altitudes are particularly difficult to find clear space in anymore.
And I would just say quickly, it has happened once. There was a French satellite in 1979, I believe it was, a reconnaissance satellite that was destroyed by a small piece of debris. And initially, the French were going to invoke the liability convention in order to get money from this. And they found out it can come from an Ariane rocket, which is French.
So no one's yet tested this liability convention because the French took the French out. Thank you. Well, let's go to the next audience question.
Hi, I'm Sarah Ream. Space initiatives seem to benefit either private companies or individual governments instead of representing humankind. I'd like to know if countries with no space programs are ever consulted about missions and projects, and should they be?
Sanjeev.
Yeah, one thing I can say is with scientific missions to space, they're often extremely collaboratory. So, for example, I work on the NASA rovers, and you would imagine that most of the science team is from the US, but actually for the Perseverance rover, about half the science team is not US. They're from multiple nations. Now, they typically are global north nations currently, but I think that will change. And essentially, it's just too expensive to do a mission entirely by yourself. So NASA usually asks other countries to maybe propose an instrument or something like that. So it is becoming broader.
Jill.
Yeah, I mean, I can say historically, it's a good point about this. Have they been consulted? And it is an issue that the United Nations has been aware of for a long time. So particularly in the 1970s, for example, the developing countries grouped together as a voting bloc to try and influence discussions that were being held through the United Nations Committee on the Peaceful Uses of Outer Space. So that's the part of the United Nations that sort of helps with governance issues. And so they were actually able to influence some areas of policy. For example, they managed to push through pre-allocation of orbital slots within geostationary orbit. There are these opportunities for discussions to be held through the United Nations Committee on the Peaceful Uses of Outer Space, but inevitably there are power asymmetries. And it is part of the language of a lot of the treaties and the discussions that we have about space that it should be for the common heritage of mankind and it's to benefit all people. But what exactly that means and how well countries actually manifest that is unfortunately, I think, often falls short. But one thing I would add that I think is good is that now that we have so much space infrastructure in place, countries don't necessarily have to have space launch capabilities in order to benefit from space activity.
A counterpoint as well is that not only do some countries not get the benefits from space, they can actually be hurt by the space activities of other people. So if you happen to be an astronomer in New Zealand, you used to have beautiful clear skies where you could observe the southern hemisphere skies most of the year, providing there was good weather. But now with Starlink going over, it goes over New Zealand a lot, right? And all of a sudden the astronomers there are losing a lot of data because there's these trails, these bright trails that are blocking a lot of the data. And they've had no say in this. Right? All of a sudden, this has happened to them. And so I think there's the counterpoint is also that even if you're not looking to be engaged in space, sometimes space can engage you in ways that you're not hoping for.
We just have one question actually related from Charlie Vaughan, who asked, do you think that the decommissioning of the ISS will have a negative effect on international collaboration in space exploration?
I think because ISS is really about the only bit of glue we've got now between the US and Russia, and often a lot of the rest of the world and Russia, actually, well, the Europeans and the Canadians and the Japanese, it will have a detrimental effect at that point if we haven't already opened up relations with Russia by then. We will want to have an alternative. In fact, 10 stations, space stations are being proposed already in the next decade. So there will be other space stations. One will be owned by India. Others will be commercially owned. And then there will be different kind of collaborations. So let's say you have a commercial space station. You will allow all sorts of countries to come on board your station. But still, there will be, I think, almost more collaboration then. There'll be more access to it. So I haven't lost hope on that one.
I was going to ask Carly, because there's a distinction here, isn't there, between the commercial aspects and the pure science? Because science has always been kind of, we as scientists, often try to ignore the geopolitics?
I think we tend to not see those borders in a way that sometimes we get in trouble with. But I think we're starting to come on board with, lots of the space instrumentation is now launched on SpaceX rockets. There is a collaboration there that's ongoing, and the development of their rocket line is enabling better space. Their new big Starship is going to launch things that are bigger, Saturn V big. I mean, it's big. It's going to be able to launch things that just previously we wouldn't have been able to launch at those velocities or at those masses. So there definitely is some collaboration going on there. But I think it's hard when your goals aren't quite aligned, right? As a scientist, my goal isn't to make money. My goal is to solve interesting questions. And I think that can potentially be a conflict, and sometimes it can just be a benefit. I'm going to buy the launch off of you, and everyone's happy because I get to be launched and you get some money, so that's a win.
With that booster, the Starship booster, so I know you're particularly interested in the outer solar system. What kind of things could you imagine launch into the outer solar system with that?
You've got two options, really. You can launch a very small thing very quickly, which if you're a bit impatient or you want to get to, say, Pluto in less than 9 years, which is what New Horizons took, you could start doing that. It starts facilitating those quicker launches. Or you can launch really, really heavy things. And that's what traditionally been, the cost has been prohibitive for that. So typically, missions to the outer solar system tend to be smaller and lighter, with Cassini probably being the exception, which was about the size of a small minibus. But then you can start really packing in the science instruments, right? You can put everything and the kitchen sink on it. You want a radar? Sure, let's go ahead and do that. You want a massive antenna dish, so you've got really high data rates to return all that data to Earth. Crack on. And so I think that's going to really change the way in which we fly instrumentation, right? It's not going to be very mass limited or power limited. And I think that potentially is a game changer, even before you get into new instruments.
Where would you go? I know this will make you unpopular with most of your colleagues because everyone has a different opinion. Where would you go next? If you could do the big Cassini-style mission next, where would you go?
I like thinking about where might life be. And so it's a bit of a boring answer because it's where Cassini went. But I think going back and flying through the plumes of Enceladus would be incredibly interesting. So Enceladus, in case that's not your favorite moon, let me convince you it should be. It's a moon of Saturn. It's about the same size as the UK. So that's it's nice and relatable. And it does big things, again, relatable. And so it has at the bottom, its South Pole, it has 4 fractures. And there's plumes of material that are coming out constantly from this. And we think that the crust there might be thin enough that the material that's coming out is from its subsurface ocean. So we know that it has a global subsurface ocean. We know it has heat from gravitational energy from Saturn. And we know it has a good amount of the right type of chemicals. And if we can fly through those plumes with some of the instrumentation that we've developed now, over and over and over again, we can really sample them very well. And perhaps we can start thinking about whether there's some chemical compounds or some structures in there that are sort of the telltale signs of life. And so I think that if we could do that, that would be super awesome, because we're doing the prime directive, right? We're not hurting Enceladus, we're not getting underneath the ice shell, we're not damaging any potential life, but we're maybe sampling stuff that's been ejected to space. And wouldn't it be cool to see some wiggly things at Saturn? I think that would be great.
I love that I know people who have favorite moons. That's great.
You don't?
Well, let's
I do now. I'm sold.
thank you. Let's turn to the next audience question.
Hi, my name is Thomas Dyer. There's a lot of talk about mining asteroids for minerals in the future. I'd like to know if you think that we've got the balance right between exploitation for materials and for research purposes, and if not, where you think this balance lies.
I can see that there are lots of cool things on asteroids that people might want, right? So example, if you're sending people to space, there's water on asteroids, maybe instead of taking all your water, use some of that. Water, there's compounds on there that you could use for construction, and sometimes there are rare materials that are hard to mine on the Earth, and that if there's an economic way of bringing those back, that maybe that could be useful too. I'm a little bit skeptical, I'm not going to lie. It seems like a really hard thing to do. How do you actually mine an asteroid? Like, there's no gravity. You stand on some of them and jump, you're going to leave it. So like, how do you physically exert a force down? It's quite a difficult thing to do. So I think the technology is a long way off. I think it's really interesting to think about. I really enjoy reading about it in sci-fi, but I'm a little bit skeptical as whether it's going to be worth all that effort in my lifetime.
Sanjeev, this is a question about the balance between science and mining.
I think they talk to each other. So I think that's the key thing, is that on Earth, for example, we know much about Earth's evolution from actually exploitation mining. We need equipment. You all have smartphones. We learn about the geology and the evolution of our planet, and the same thing will happen because we're going to mine rocks on asteroids. And so we go to asteroids to study those rocks, to understand the evolution of those asteroids, where they come from, the chemical framework, etc. And it's those very minerals that we'll be mining. I do think it's some way off, but there are a lot of startups who are very excited about, platinum group elements and all sorts of other things. But in some ways, I think, well, if we can mine a few asteroids rather than large areas of Earth, is that not better? I mean, there's quite a lot of asteroids out there, so perhaps it's a nice balance.
I think there's a couple of big things for me on asteroids. One is, can we overmine a particular asteroid? They are quite small, as Carly sort of mentioned. So the question for me would be, are we going to allow people to completely use up a celestial body like an asteroid? Are we saying that there's so many of them that we don't really mind, so maybe that's fine? But if we do use up a significant amount of an asteroid, then that mass of the asteroid will change hugely compared to what it was. Therefore, its trajectory is likely to change. So we have to be very careful that not just our activities of perhaps making explosions that might create the material that we can then collect and mine in that way, but the overmining of them that could put them on a trajectory towards other satellites, possibly even the Earth. So we have to be careful of that.
That's a good point. Yeah.
So we talk about the timescale, and I suppose there are many different views about timescales, but the legal frameworks are being developed. So that suggests that at least that some people think there's an urgency.
Yeah, exactly. It's interesting to me because, so after the last major treaty failed, the Moon Treaty of 1979, which was intended to unpack some of these issues around resources, everything kind of went quiet for a while. And now, just since 2015, 4 countries have passed domestic legislation saying that their citizens could claim resources that have been extracted from space. And then, of course, the United States has now introduced what they call the Artemis Accords, which is, again, meant to address this issue of extraction of resources on the lunar surface, and it says that we would allow this. So there is a sense, I think, within the legal community and the governance community that this is imminent. It's still very much a question up in the air, though, because some people say, no, the Outer Space Treaty says you can't claim any celestial territory. Other people say, well, you also can't claim the high seas, for example, but you can extract fish. So we'll see these resources as something different than sort of celestial territory. Other people say if you bring it back to Earth, then it ceases to be celestial, and therefore you can claim it. But there's also, yes, people are always looking for legal loopholes. But I think it also comes back to this question of who benefits, because there's also questions of if we were able to bring resources back, technically from the legal perspective, they should be distributed and benefit all humankind. So yeah, there are different ways to think about this, and it's very much a live discussion in the international community at the moment.
I have a fun question from Paul McGregor. He said, my wife purchased a star for my birthday. Was she conned? Does anyone know? But maybe legally, are you allowed to buy a star according to the treaties that we have?
This is fascinating, and it goes to show how whatever law there is, people try to get around it and find loopholes. So the Outer Space Treaty says that no nation state may lay claim to celestial territory.
Your wife, however.
So these companies are saying individuals or companies can sell plots of land on the moon or sell stars. The one thing about it, sorry to disappoint your wife, Paul, but a lot of these companies have resold the same plots over and over and over again.
Stars are very big.
Do you know which star it is?
The brightest one in the sky. But it's true in the solar system as well that you can't just go in and name things. When I was on New Horizons, which flew past Pluto, and there was a whole thing about how you name things, because names are important. What we call things are important. Who we honour is important. But one of the things you can name relatively easily are asteroids. And so if you discover an asteroid, you can name it after somebody, and they don't have to be dead yet. Usually people have to be dead to name them in space. So it's if you want something named in space, go for an asteroid. Go and find some asteroid discoverers and chat them up and see if they'll name one of those after you, because they really do mean something, and they're recorded by the Minor Planets Center. And if it comes and hits Earth, your asteroid will have hit Earth, and it'll be called you. So you know.
Did a crater get named after you then?
So on Mars, we actually need so many names because basically every single rock we analyze or look at gets a name. So they're called informal names.
Yeah.
And there was one place where we named a map quad after a place in northwest Scotland, the Torridon. It's a Torridon quad. And we spent 2 years in that quad. So when I go to Scotland, I'm driving around. Every place name is actually a rock on Mars. I know the rocks intimately, but not the places. I was able to even name the district in Edinburgh I used to live in on Mars.
Right. We have an audience question actually related to this, but essentially who owns bits of space or how we divide it up.
Hi, my name is Rachel Dawes. Historically, humans have laid claim to ownership of land on planet Earth through physically staking claim via exploration or conquering it through invasion. Does the panel think that ownership of moons and planets in our solar system will be achieved any differently?
I think the moon's coming quite soon, actually, and it concerns me that parts of the moon will certainly be claimed, if not legally claimed, but in practice, because the Artemis Accords state that once you've got an operation happening there, then no other organisation, entity, whatever, is allowed to interfere with that. And the UN is kind of sort of accepting because it's talking about safety zones around those operations. But actually that means that basically once you're there, you put a whole load of, let's say, little nuclear reactors all around the perimeter of where you want to be, and you've pretty much claimed that part of the moon. Nobody else can use it. You don't own it, but tantamount, right?
I suppose the natural question is there's a lot of it. So what is it that's going to
Bits
cause
of the moon,
conflict?
Bits of the moon that are really, really useful that we don't think are elsewhere on the moon. So where there's large water pockets, for instance, there are some parts of the moon where you've got pretty much 24/7 sunlight, and there will be other parts where it's sort of minerals are concentrated, where we will want to claim those areas. So it bothers me.
I'm more hopeful for Mars. I think, we really will go to Mars for exploration, for science. I think it's unlikely we're going to go to Mars for mineral exploitation. It's just too far away. And as I've said, science is so expensive. To go to Mars is so expensive. It requires many nations working together. So I think, if one nation did decide, the other partners would pull out. They would say, no, you can't really do that. So I think I'm hopeful that collaboration and multiple teams will actually prevent that claiming.
I suppose it is the only other planet we can go to. So
Yes.
we will go there eventually.
Yeah, I'm certain we will go there. I can't envisage us going beyond there at the moment. We'll have astronauts on Mars, but I think it will require many nations to work together to make that actually happen.
I have to ask you to guess. Astronauts on Mars? should we have one of those straw polls? What do you think? Because, SpaceX would say 10 years, 15 years, wouldn't they? Well, they're saying even less, perhaps. So what would be your instinct? Having landed something on it?
Not personally, but
perseverance.
I'd say beyond 2050, not sooner than that.
Well, I'd go for the 2040s, late 2040s, and I think we will probably go, actually, ironically, straight there, using a SpaceX rocket.
And it will be an 8-month, 9-month trip with that technology. Right.
Yes, it's looking like it doesn't necessarily have to be that long. It could be a bit shorter, but it's certainly a few months. And then, of course, you've got to align Mars and the Earth up before you return. So it's going to be a long round trip, definitely.
Would you fancy it?
Yes, I'm saying by the time it gets to the late 2040s, or maybe if Sanjay's right, after 2050, I'm not sure that I'd fancy such a cramped, tight spacecraft for so long. But now, I'd go now. I'd go now. Yeah.
Would you, even though it's probably a 2-year thing?
I think that's, but, as long as I'd come back, I'd want to be reasonably sure of coming back.
I think astronauts are built of different stuff. To be, would anyone else on the panel actually 2 years?
If I could take my cup of tea, yes, maybe.
Wouldn't you go, Brian? You wouldn't go?
I don't think I'd want to go into something so small for so long a time. I don't think I'm.
Window.
Yeah, I'm made of the wrong stuff. Well, we have a question actually which is related to the settlement of Mars and other worlds.
Hi, I'm Justin Fryer, and I'd like to know what you think the ethical considerations are of settling a new world. If we discover even simple microbial life on a place like Europa or Mars, would that discovery affect the debate over who has a right to live there?
I would like to go to Sanjay first, because you might mention that I know you haven't discovered life on Mars.
Thank you.
But it might be worth just in context.
You're the
to say that-
closest of the panel. that
Yeah,
might have
so
done.
there
So-
are interesting results from
So
Mars.
this is September, so September 25, so you all know when. Perseverance has just reported this major finding of features in Martian rocks. We call them potential biosignatures. That's features we see in the rocks that can be explained either by non-biological processes, but also biological processes. And this is the first time we've seen something like that. And we say that this is something that warrants detailed investigation in Earth laboratories. So we haven't discovered life, but we've found something that, if we saw it on Earth, could be explained by life. And I think that's a major step forward. We're obviously looking for ancient life. We're looking at rocks that are 3.5 billion years old. That's when life got going on Earth. But who knows if there's extant life, microbes deep in the subsurface. And my big concern about, humans going to Mars is really, are we going to transport the life that we discover on Mars that actually came from Earth? And so this whole issue of contamination, I mean, there's scientists who, that they work entirely on that problem. But I think it's a really serious consideration. If our big scientific question for Mars is, did life arise elsewhere? We don't want to take it with us when we go to Mars.
And we do have a lot of spacecraft on the surface of Mars, both inactive and active. So could you just describe briefly what precautions we take to stop transporting life from Earth to Mars?
We tend to go to areas that are devoid of any evidence of possible running water. And in fact, we on a daily basis with the rover missions have to report if we've seen anything that looks potentially like running water. If there's a gully that might have contained water, if you have water and you're carrying microbes, they could quickly proliferate, basically. So, the desert areas, maybe not so. And we're definitely not allowed to go to places without a very clean spacecraft.
And you faced this, I suppose. Well, Cassini did, because obviously the Huygens lander landed on Titan.
It did. Yeah, so Titan, another excellent moon. This one has an atmosphere, so less my wheelhouse. It has chemicals, and we think it has heat, and so it's another big prospect. And we think that it has a liquid methane rain, so it does have lakes and erosion and all those things. So when we talk about taking things to these worlds, we do have to be mindful of that. And I'm also helping with ESA to help developing their next big class mission, which is to go to Enceladus, which is now everyone's favorite moon, to land on it. And so how we keep it safe is a really big discussion. And normally the way it's done is you bake it out. Right? You take your spacecraft and you put it into ovens and you try and kill off all the microbes that way, and you keep them in clean rooms, and you do what you can to keep them clean. But as we all know, when we go to new places, we bring germs with us, and we've got a long history of doing that. So it is a real concern. On Enceladus, it's full of water. There's no dry bits, so it's an increasing problem there. The last thing you want to do is destroy an ecosystem before you've explored it. The other part of that question is about, so say those rocks do have extinct life in them. Does that mean we never get to go to Mars? Does that mean we never get to have a base on Mars? So I think that's an ethical question that I don't know the answer of, but it certainly raises a lot of red flags. And I think people would want to have that full discussion before we, pack Elon Musk up in a SpaceX rocket to go there.
I mean, Helen, that was the spirit of the question, I think, was should we go and essentially colonize whatever, build bases on Mars? Even you said you wanted to go to Mars. Would you still want to go to Mars if there were Martians? And I don't mean big Martians, I mean little microbes.
I think I'd want to make sure that I wasn't harming those little microbes. But of course, the question always is, you can never prove that there is no life there. We can't prove a negative. We just have to be, make our best efforts, I guess. So at some point, we have to engage in all this international dialogue about when is the right time then to go to Mars, given what we know about it.
I mean, the scientific potential of discovering, especially that there was a separate origin of life. It's one of the biggest scientific discoveries of all time. Yeah. So damaging that possibility would be difficult, wouldn't it? Difficult to contemplate.
Absolutely, I think but if you don't go there, sometimes you can't figure it out either. So I can see that some of the studies that need to be done, require very complex machinery, and space robots are brilliant and they do a lot of things, but there are some amongst us that would argue you need people to operate some of them, and that requires people to go there. I'm not one of them.
Jill, is this an area that is discussed?
Yes. So it's actually an area that I just find really fascinating. But here come the lawyers. There are some regulations. Actually, it's not law, but there are regulations that have been established by a Committee on Space Research, which is widely adhered to, which is about this forward and backwards contamination. So making sure or attempting to not take anything out, but also to sterilize things when they come back so we don't bring anything back in. I've actually discussed at the United Nations Office of Outer Space Affairs in the past whether or not there should be sort of a scale in terms of what ethical obligations we have based on whether it's a dead environment or if we're talking about microbial life or sentient life up to intelligent life. And then getting into the really eccentric side of things, there are some people who say if we do encounter intelligent life elsewhere, it might be robotic, given the way that our own evolution is evolving. So does that change our ethical obligations? But in the moment, this is all still very much in the realm of conversations. I also would mention, I think there are interesting questions about who we want to represent us on these missions. So are we comfortable with it being individual countries? Do we want companies to represent us? I'm not sure we necessarily have a whole lot of control over that because a lot of it depends on who has the money. But, we're talking about the billionaire playground increasingly these days. And so I think that's another interesting ethical area. One other thing I wanted to add, and this often scares people if you haven't heard this before, is we have actually put creatures on another surface. In 2019, an Israeli spacecraft crashed on the moon and scattered tardigrades across the surface of it, which are extremophiles.
By accident or deliberately?
It was meant to be a soft landing. They intended to have them on there. They didn't tell anybody they were on there. They're encased in resin, but because it crashed, there would have been heat and it scattered them, and we don't know what the status of them is.
What they're doing. Yes, quite.
They need water to be able
there now to discover life on the moon.
I just want very briefly, because you mentioned actually Mars sample return or the necessity actually to, if we want to confirm the observation you've made of this potential biosignature, we've got to bring that stuff back. So there is always the question of you bring life or even samples from another world back. What do you do? How do you prevent contamination of the Earth?
Well, I'm definitely not letting them in my laboratory. I don't want to be anywhere near them because we don't know what's in them. So they'll go into a special containment facility that will be built and analysed by robots in this, and no humans initially will be allowed anywhere near them because of the same, you don't know what's going to be in them, but also the human interaction with those samples.
There have been films, haven't there?
Yeah, that's right.
The Andromeda strain and others.
Yeah, so I think we'll have to be very careful. And, Mars sample return at the moment is delayed, but maybe that delay will enable us to develop the strategies that we need to actually analyse those samples. But, to really make progress on this question of life elsewhere, most scientists think that we need the samples back on Earth.
Well, thank you. Let's go to the next question, please.
Hi, I'm Peter Gordon. The 1967 Outer Space Treaty prohibits placing nuclear weapons or other weapons of mass destruction in orbit. Do the panel think such agreements will be upheld in the future? And how would a treaty like this be enforced if challenged?
Jill.
That's me. I really hope so. It's worth noting that nuclear weapons have been exploded in space. Both the Soviet Union and the United States were exploding nuclear weapons in the 1960s, which was partly why we brought in the Partial Nuclear Test Ban Treaty and why the Outer Space Treaty specifies that there are no weapons of mass destruction in space. So there are other types of conventional weapons that are being developed or used in space. Interestingly, I learned recently that actually guns have been into space. The Soviets astronauts used to carry guns, not for use on each other, but in case they landed in a rural part of Siberia and needed to use it on animals for safety.
In my training, I had to train to use it.
I didn't know that. The thing is space is already very much militarized. So to some degree, that ship has sailed. As the price of space comes down, we're going to see more rogue entities be able to have access to space. A big concern right now is being able to hack satellites, for example, which could then be turned into weapons. The one thing I'll say is that when it comes to weapons of mass destruction, we haven't used them on Earth since 1945. So I don't see why it would be more likely that we would use them in space. And if we get to the point where we do, I think we are in a whole lot of trouble.
thing is, what is a weapon? Because actually our infrastructure relies so much, as Brian said in the introduction, it relies so much on space anyway. So all you have to do is to disable a country's national grid, for instance. And you could do that relatively easily if you can hack into their satellite. So Jill mentioned cyber, all this cyber stuff. So hack into a satellite, disable somebody's national grid. You don't need a weapon of mass destruction, but you've destroyed the country.
But it only covers nuclear weapons, and there's lots of weapons that aren't, as we've touched on. But I mean, just throwing something very big and heavy at the Earth can do a lot of damage. I mean, that's it. When we think of what happened to the dinosaurs, it wasn't a nuclear weapon. And so, whilst that is really important, and I'm very glad it's being governed, there's lots of ways of weaponizing just old satellites and things like that are potentially quite dangerous.
Well, this is often discussed as well in the context of asteroid deflection, isn't it? Because if you can deflect an asteroid that's on a collision course with Earth, you can also deflect them onto a collision course with Earth.
Anyone that reads The Expanse knows about that. So
Terrifying.
Well, let's go to another question about the exploration of other planets.
Hi, my name is Bridget Rendell, and my question is, if we begin living on other planets, how might that change our relationship with Earth and with each other? And could we end up repeating old patterns of conflict, only now across worlds instead of borders?
Jill, the question was about, I suppose it's a danger that we repeat the same mistakes, because the way we're discussing things at the moment, we're just going to impose the same framework on wherever we go. So is it possible that it might be useful for us to develop a different framework when we're there?
So is there a chance we'll repeat? Yes. Next question. Yes, it's a concern. And again, this is where space kind of taps into the extremes. So on the one hand, we also talk about the idea that as we go out and learn more about our own origins, that we would potentially see ourselves more as a collective, recognize our common humanity. Or it could be this sort of redrawing of identity lines. One of the things I'm interested in is the way I think there are feedback loops between our activity in space and then how it kind of reconstitutes the way we think about ourselves. So the most obvious example is the environment. So we went out looking into space, then we turned it back on ourselves, which helped inspire the environmental movement. Also things like cooperation and diplomacy. We established the International Space Station, which then reconstitutes the relationships that we have on Earth. So I do think that it's going to impact the way that we identify and the way we see each other, but absolutely there are also risks that it could re-entrench old conflicts and competitions.
The saving grace might be, when this happened in the past, in historical past, most of the world didn't know it was happening. We're so globally connected now, everybody would know, and maybe there would be such an outcry that it might force changes. I'm not fully hopeful, but I can hope that maybe that outcry, partly because of the scientists, the science is an international collaboration, collaborative process, maybe that would cause a change.
Yeah, I hope the whole come in peace thing holds. To my mind, space is about exploration and is exciting. And I think in the near term, like everyone has said, it's so hard to do, it's so expensive, and you're so vulnerable when you're there as well. There's so many ways in which you can die in space. She says, not trying to make eye contact with the astronaut, who knows that only too well, but who likes being on the ground. So I can see that whilst we feel vulnerable, it's probably a safe place to be in. And then as we get more and more comfortable with that environment, it might change. But I still hope that we come in peace and play nicely with each other.
Well, let's go to the final question, which is it's the widest ranging question, I think.
Hi, I'm Andrew Westerby. I'd like to know, if humanity unites to share the final frontier, what one unbreakable rule do you think will guide us in forging our future among the stars?
Well, that's deep, isn't it?
That's a tricky one.
I would say something like stewardship of space for the benefit of humans and all other life.
Yeah, I would hope that people would, really think about the common good and think about it as a relationship. Maybe we need marriage guidance counselors up there. So discussing the different nations.
So your answer to this magnificent question is more marriage guidance.
You know what nations are like, Brian. Come on.
Would anyone like to add?
Don't be a jerk. I don't know. Is that too simple? I don't know.
My thought initially, actually, funnily enough, was not about law, but more of a principle. Going back to kindergarten, this idea of do unto others as you would have done unto yourself, which could be summarized as don't be a jerk, and that applies universally.
That's sadly all we've got time for, so all that remains is to thank our wonderful panel, Carly Howitt, Jill Stewart, Helen Sharman and Sanjeev Gupta, and to you, our wonderful audience. Thank you.